We're very fortunate to have Stefanos to...
Pleasure to be here.
And Stefanos' background, he's got deep experience in machine learning. He's got his PhD from UCSD and artificial intelligence. And for those of you who don't know, UCSD is one of the best schools in the world for large-scale computing and other things, very big in the Hadoop development, and just a lot of geniuses come out of there. So it's great to have you. We're going to deal with an incredibly important topic that I think is under-discussed, actually, which is explainability in AI. Ethan Mollick had a wonderful post the other day and talked about, he said, you know, we shouldn't be talking about these things as agents. And Ethan's a professor at a business school down in Pennsylvania. I think it's called Wharton. Anyway, I've
heard of it.
heard of it. And he said we should talk about dealing with magicians because, you know, and here's a person who is a computer scientist and also a business academic, and he's talking about the fact that he watches these things and he doesn't understand how they do what they do and why they do what they do. And a part of me, you know, it's like, hey, that's kind of a clever and interesting way to think about it. Another part of me was absolutely horrified when you think about what's going on. So Seekr is a leader in explainable AI. So why don't we start with the basics, Stefanos, which is, how do you think about what that word means?
Yeah, so explainability and explainable AI, I think at a kind of like a grand scheme of things, is providing someone the ability to explain a model's or a system's decision-making and underlying processes. Mm-hmm. And, you know, today's kind of world of AI is all about agents. AI agents are everywhere. The way I like to think about agents is essentially systems that interact with their environment and decide on their own when they're done.
Yes.
Versus, you know, an LLM where you simply ask it, or a chatbot where you simply ask it a question, you get an answer, and that's it. Agents are much more intelligent in the sense that they, you know, they're able to accomplish much more complex tasks. Mm-hmm. They traverse graphs of possibilities that are much richer and much larger than what a traditional LLM or vision language model would, which, you know, they have the ability to plan, they have the ability to select between different tools, the web, code execution environments, a large number of things, but ultimately, you know, they are non-deterministic systems. Right. And when an agent makes a decision that is flawed at the beginning of its execution graph, that error or that hallucination or whatever we want to call it will propagate all the way to the end.
Yes.
And in order to be able to rectify that, in order to be able to understand what's going on, you need what we call explainability. You need the tooling, you need the technology, you need the capability to actually open the black box, understand what happened in the agent's execution process, and if need be, contest that decision, that outcome. What we call at Seekr contestability, which is making explainability actionable, bringing in the human in the loop to actually teach the system how to become better, how to get better at the specific task.
Yes.
So that's sort of like in a nutshell, how I think of explainability.
Yeah, and I think it's interesting. One of the things when I went to work at PwC for a while, I really started to understand not just audit processes and tax processes, but really compliance processes in a way that I hadn't before, including the $5,000 fine I got for buying my kids some stock I shouldn't have. Anyway, when you're dealing, I think most organizations, if not every organization, have certain decision processes that have to be explainable. Lots don't, right? But I know at PwC, when the regulators came in and they wanted to know about your audit process or your compliance process or your risk processes, you had to be able to give them in detail, and you even had to show some people who were punished for stepping over the line. which is what they told me when I got charged $5,000. The so as you think about that, as I understand it, and tell me if I've got this right, you folks believe in order to deliver that, you have to start really from data and curation, training, and then model execution, and then evaluation at the end. And if you don't have that full value chain, you really can't do explainability. Is that correct?
Well, I think sort of, yeah. I think to a certain degree, yes. So talking about, taking a large language model or an artificial intelligence model and, deploying it for an enterprise application or for a business application, there's essentially two paths. One is what we call inference time operations. So basically take that model and wrap it into an agent, connect it with different tools, connect it with different, the web, like I said, or code execution environment. Give the model the cheat sheet or set of cheat sheets that it needs to actually accomplish the task. So this is the first kind of path. The second path is train the model, take your corpus of private data, turn it into something that the model can learn from, and fuse that knowledge into the model's weight.
Yes.
So I think we, at Seekr, we actually tackle explainability for both those things, right? Like the providing sort of like the tooling and transparency into the AI system, whether that is an agent or a specific model, trace its decisions back to data, identify why a particular call was called, enable the human to step in and contest that model's decision.
Yes.
And say, this is not right, or this is right, because sometimes this is important as well. You need that reinforcing signal for the model to learn. So that's it in a nutshell.
And there's a lot of research that seems to show that trust is a huge issue in AI models and AI adoption. At the same time, you'll talk to some practitioners who are out in the marketplace, and they'll say, we don't really see it that much. Yes, I understand the papers say this and the surveys say that and so forth, but on the ground, there's not a lot of people who are really pushing back on the vendors for explainability. Could you give us an idea of what are some of the areas where you folks are seeing that real need and understanding and traction?
Yeah, so look, when we think about scaling AI,
yes,
as I said earlier, it's focusing on real problems, right? Like real automation tasks, not just chatbots, not just copilots, focusing on true AI that it's autonomous.
Yes.
And as these systems and things keep evolving, we will and we are be having the systems making decisions of real impact. AI systems will be, potentially deciding who gets a loan or who gets accepted into college, or, making specific decisions about national security. So the impact is tremendous.
Yes.
These are the domains that we operate in. These are the industries that we serve.
Yes.
And explainability, trust, the ability to use AI as sort of like a force multiplier to the human to solve complex problems and increase the productivity of us as humans is where we focus on.
So it's so interesting. So as you get to the point where you're actually executing the whole task, and you look at things that traditionally have been domains of regulation or oversight, such as student loans, such as student admissions, loans, and so forth, that is really an area, as well as national security issues. That's really an area where you're seeing a receptive conversation.
Yeah. We call these industries critical infrastructure. Finance, defense. A lot of these industries that are very regulated.
Yes.
Beyond sort of like building co-pilots and AI models, accuracy is paramount. tolerance for things like hallucinations, errors.
Yes.
It's little to none.
Yes.
So yeah, that's where the only way to sort of achieve that level of accuracy is through being able to open the black box,
Yes.
the AI black box, and actually act on the outputs when they're wrong.
Yes. I don't know if there are questions in the audience. If there are, I'll be happy to take them. I've got plenty more, so just give some thought. How hard is it for the big model vendors? Let me put it this way. Can explainability be retrofit back into some of these large models? Because you don't get very good, I'm asserting you don't get very good explainability right now.
Well, yeah, so in order to do true explainability, you need to be able to trace models' decisions back to where the models learn from.
Yeah.
Right? Like you need to be able to trace a model's decision back to the influential training data points that taught the model that behavior. So to answer,
if you don't have the sense traceability accounting built into the way you put the model together, it's very hard, I would imagine, very hard to do that.
it's really hard, yeah. And you know, there's a lot of challenges around. You know, you would never get access to the data that were used to train these models from, you know, the big models. But also, it's a tremendously complex thing to reverse engineer. Essentially, I think that it's almost like as intelligent as the human brain.
Yes. Yeah, it's interesting. I had this, I was reading some of your stuff, I had this vision of my good friend Alan Kay, who talks about the Windows operating system as basically a garbage dump with a nice cover, with hundreds of millions of lines of code in there, that in a certain way, from a semantic understanding perspective, these large models are very kludgy, right? I mean, in terms of be able to get, they've managed to compress, 40 years of technical debt into 5, which is really impressive. From a semantic explanation standpoint. So you're not optimistic that they're going to be able to reverse engineer the stuff into it. If they're going to do it, they're going to have to build it out in their new models.
Yeah, I'm not sure exactly what they're going to do.
Yeah.
But I think that they all know that explainability is really, really important.
Yes.
The ability to actually tie models' decisions back to data, back to neurons, back to the neural pathways that the models follow when they make decisions. Yep. They all know that, but we haven't sort of seen anyone productizing that or making it available to the enterprise.
Yes. We have one question over here we have time for. Yes, can we get a...
how you solved it, and why your solution made a difference.
Yeah, so let's see. So as I said earlier, we sort of operate in the critical infrastructure space. So we work with companies in the financial sector. We work with, a lot of telcos around the world. And the AI systems that they deploy are basically complex agentic workflows where auditing the full agent's trace and computation graph and being able to step in, decide, or step in, understand why the agent called a particular tool, or which document from your vector database, which chunk from your vector database in a RAG application, say, was influential, and step in and kick it out, right? Remove it from your database, or redefine how the agent calls the tool. So I'm not sure if that answers your question, but it's all sort of like along the lines of you have an AI system. Before you get it out to production, you need to have the right tooling, the right technology, the right transparency, the observability to step in, change what needs to be changed, audit the system's decision making, and in order to bring it to the accuracy level that you need.
And as I understand it, it sounds like you're not you can't disclose that particular application. One in particular that you have told me about is a car repair organization that is allocating across many repair personnel and activities against a car, and people want to know, why is my bill this way? And it serves two functions. One is to optimize the allocation of resources so that they go to it does a better job of going to the very best, the best talent going against the most difficult problems. And then when the customer says, why is my bill this way? Why did you decide to do this? It can explain it in detail. So that would be one example. So you get utilization benefit on labor and parts, and you get explainability benefit with the end customer. So that's one they can talk about.
That's one of our customers.
Yeah.
But yeah, there are several others. Government use cases, telcos, like I said, where this level of transparency is actually key to achieve the high level of accuracy.
Well, awesome. Unfortunately, we're out of time, but thank you so much, Stefanos.
Pleasure.
And please join me in thanking Stefanos. Thanks so much. Awesome.